Hi all, welcome to EQUICONCEPTS. Today, we'll be focusing on the topic from Standard 10 Chemistry, which is chemical reactions and equations. So what are the topics we'll be covering under this? First, we'll be seeing the introduction, which basically explains what a chemical reaction is, and second one, we'll be studying about chemical equations, that is, how to write a chemical equation and its balancing. The third, we'll be seeing the types of chemical reactions, which explains all the different types of chemical reactions. Next, we'll be studying about the effects of chemical reactions in real life. Introduction. What exactly is a chemical reaction? This experiment here is a very interesting one. First, take a clean magnesium wire and then show it to the direct flame of a Bunsen burner or a spirit lamp. What do we observe here is that a dazzling white flame. So what is this dazzling white flame? It's nothing but the magnesium reacting with the oxygen in the air to form magnesium oxide. How do we write this in an equation? 2Mg plus O2 gives MgO on heating. This second experiment is also an interesting one. We take lead nitrate in a test tube and then we add potassium iodide. What do we observe? We observe a beautiful canary yellow precipitate. This precipitate is nothing but the lead nitrate reacting with the potassium iodide to form lead iodide precipitate. How do we write this in equation? PbNO3 twice plus Ki gives PBI precipitate plus 2KNO3. This PBI is also denoted by a down arrow, which denotes the precipitate. Now, the last experiment. So we take a conical flask and then we add dilute sulfuric acid into it. To this, we add 2 or 3 zinc granules. What do we observe? This is known as effervescence. These are nothing but H2 gas evolving. How do we write this in equation? Zinc, that is Zn, plus H2SO4 gives ZnSO4 plus H2. The H2 is the gas evolved. What are the observations we see in all these? That is, we see a change in state, a change in color, and then there's an evolution of gas, and then obviously there is change in temperature, which basically gives us what a chemical equation is. Moving on, chemical equations. Now, how do we write a chemical equation and then how to balance it? How do we write a chemical equation? Taking our first example, magnesium plus oxygen gives magnesium oxide. The magnesium and oxygen, we'll be noting it as reactants because they are the ones that are going to reactants, and then which forms a product, that is the magnesium oxide. How do we write this in equation? What is the symbol of magnesium? We already know that it's Mg, and that of oxygen is O2. So putting that together, we see that MgO is formed. So how do you balance a chemical equation? Now we have all studied about the law of conservation of mass, which states that mass can neither be created nor destroyed in a chemical reaction. We'll take an example. Al plus HCl gives AlCl3 plus H2. We are supposed to balance this equation. Step 1. So what do we do here? We take all the number of ions in all the elements in the equation. So first we take aluminum. Aluminum number of atoms in the reactants is just 1, and in the product is also it's 1 in AlCl3. H over here is also same. In the reactant side it's 1, but in the product side it is 2. And Cl on the other side, in the reactants it's only 1 in HCl, but then in the products we see there is 3 Cl in AlCl3. So how do we balance this? So what we do is we take the highest number of atoms in this reaction, AlCl3, and in which Cl3 has the highest number of atoms. So we try to balance Cl3 first. So step 2, number of atoms of Cl in the reactants. Initially it's only 1 in HCl, but then in the product it is 3 in AlCl3. Now how do we balance it? We take 1 into 3 in the left side to get 3. Note that we can't take it as Al plus HCl3 or as HCl the whole 3. We add a 3 on the left of HCl. This equation is known as a partially balanced equation. because only Cl has been balanced as of now and the other atoms haven't been balanced yet. Now we are trying to balance hydrogen over here. Initially there are 3 hydrogens in 3 HCl. That is, after balancing Cl we see there's 3 HCl, but in the product sides there are only 2. So how do we balance it? So in reactants we make it as 3 into 2, that is 6, and in the products also we do that 2 into 3, which also gives us 6. So we write Al plus 6 HCl gives AlCl3 plus 3 H2. Now there's a disturbance in the equation because we already did 3 HCl and balanced 3 Cl. Now it has become 6 Cl. How do we balance that? So on the reactant side the 6 stays as it is, and in the product side we add 2 AlCl3. And then step 4 is to finally balance the aluminum. Initially there's only 1 in the reactant side, but then in the product there's 2 because of 2 AlCl3. To balance that, in the reactants we add 2 Al. So the reaction will now become 2 Al plus 6 HCl gives 2 AlCl3 plus 3 H2, and hence we obtain a balanced equation. Moving on, the interesting side of this chapter, that is the types of chemical reactions. What are the types? There's a combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and redox reaction. Combination reaction. So this is also explained by a experiment. What we do is, in a beaker we take water and then we add calcium oxide to it. What we see here is formation of bubbles. Calcium oxide reacts with the water to form calcium hydroxide. Now this CaOH twice is also used in whitewashing of cement. With this, what do we conclude? That a reaction in which a single main product is formed from 2 or more reactants, that is a combination reaction. There are other examples of combination reactions too, which is burning of coal, that is carbon plus oxygen gives carbon dioxide, and then formation of water from H2NO. H2 plus O2 gives H2O. Decomposition reactions. There are 3 types of decomposition: thermal decomposition, photolytic decomposition, and electrolytic decomposition. By the name itself we see thermal decomposition is nothing but decomposition by heat. What we do is we take FeSO4, that is green color crystals, in a test tube, and we burn it. Fe2O3, that is a reddish brown product, is formed, giving out SO2 and SO3. This FeSO4 loses its water of crystallization, which gives it its green color. Next reaction is electrolytic decomposition. In this reaction we take 2 test tubes filled with water and then immerse it in a beaker full of water, the same water, and then to one test tube we connect the anode and to the other we connect the cathode of a 6-volt battery. In these test tubes you see gases will be formed. In the anode we see oxygen is collected, and in the cathode we see H2 is collected. This is the decomposition of water into H2 and O2 by the effect of electricity. So in the equation we write it as 2H2O in liquid form gives 2H2 gas and O2 gas. Photolytic decomposition. Now we take AgCl, that is silver chloride, in a china dish and leave it under the sun. What happens is this AgCl becomes greyish in color. This is due to the formation of Ag and Cl2. This is the same in the reaction of AgBr2, that is silver bromide. Now this silver bromide is used in black and white photography. What do we conclude here? That a reaction in which 2 or more products are formed from a single reactant is known as a decomposition reaction. Displacement reaction. You know the color of copper sulfate. Copper sulfate is bluish in color. Now we add an iron nail in this. What happens later is that the copper sulfate solution becomes into a dull greenish color, and then there's a red color coating on the iron nail. What actually happens is the copper sulfate reacts with iron to form ferrous sulfate, and then there's deposits of copper. So in equation we write it as CuSO4 plus Fe gives FeSO4 plus Cu. This copper is the one that is deposited on the iron nail, and the FeSO4 is the green color of the solution. What do we conclude here? We see that the iron has displaced the copper to form FeSO4, a reaction in which a highly reactive metal displaces the low reactive material is known as a displacement reaction. So how do we know that this is more reactive and that is more reactive? That's why we have a reactivity series. The reactivity goes as per this: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold and platinum. Next we will be seeing double displacement reaction. The same reaction of displacement, but here there is double displacement. How do we see this in an experiment? We have barium chloride in a test tube, and to this we add sodium sulfate. This immediately forms a white color precipitate of barium sulfate. And equation we write it as BaCl2 plus Na2SO4 gives BaSO4 plus NaCl. What do we conclude from this? Any reaction where a precipitate is formed immediately when two aqueous solutions are mixed is known as a double displacement reaction. Next we see redox reaction. So basically we heat copper. This copper reacts with the atmospheric oxygen to form black colored copper oxide. Okay, when this copper oxide is reacted with H2, we get the same copper back, that is the reddish brown copper back, with H2O. What is this reaction? What do we see here? This copper, the first reaction, gains oxygen to form a copper oxide, and this copper oxide loses oxygen to form copper. So in a reaction in which there is gaining of oxygen is known as oxidation, and the reaction in which there is reduction of oxygen is known as reduction. In this reaction we see that there is both oxidation happening and then reduction is also happening. In the oxidation, that is, the H2 gains O to form H2O, and the COO loses O to form Cu. So in a reaction in which both oxidation and reduction occurs is known as a redox reaction. The last topic we see is effects of chemical reactions in our day-to-day lives. First thing we see is corrosion. What is corrosion? Now you all know the Statue of Liberty. It was actually built out of pure copper, which is reddish brown in color, and then eventually formed patina, which is now the same green color appearance of the Statue of Liberty. This is basically what corrosion is. And the last topic we'll be seeing is rancidity. What is rancidity? There's an oily, bad, pungent smell you get if you leave a packet of chips or something outside for a long time. This is due to the oxidation of these oils. Now this gives us the pungent smell. So guys, that's it. We have finished this topic. I hope everyone understood what I told.